Hello, in this second week lab, I took into consideration the flame that would be involved in this lab experiment. So some of the preparations that I made was to make sure that I had a good work area without any loose items, anything that'll be able to catch on fire, and my clothes were appropriate as to not having anything that can come in contact with the actual flame. I also made sure to wear my safety goggles, to wear gloves, just so nothing can come in contact with my eyes or my skin. And I took great care in handling the chemicals just to make sure I would not come into contact with any of the chemicals. Now, biggest safety hazard, as I said, would be the open flame, since the chemicals were not particularly too dangerous. Um, Accidentally contaminating some of the lab utensils that I'm using. How can I tell? Well, it's in the reaction that I would get if I didn't properly sterilize the equipment. I would get a pretty bad reaction, pretty dull, invisible reaction. Which substance did I like observing the most? I would say that the lithium chloride for me was the one that I enjoyed observing the most. One, because it was a very clear, obvious reaction. I saw the color and it was very highly noticeable. The least favorite of mine to observe would actually be the potassium chloride. That, to me, in my opinion, was the most difficult one to observe the reaction. Though after reviewing the footage, I was able to see that there was a hinge of blue there. So I would say that was the most difficult one to see. How did I determine the wavelength of light observed? By using the chart that was given to us in the lecture notes. I was able to compare the colors that I got from the reactions to the actual chart, and I was able to come up with the wavelength. My concluding statement for this experiment is, depending on the atomic structure of the actual substance, that will play an important role on the wavelength that it would fall under. Some of the resources that I used, especially in the beginning of the lab, just making sure I was preparing myself in a safe manner to actually do this lab, were chemistry videos on YouTube, making sure I knew where to put the actual substance on the flame, if it was better to put it on the very tip of the flame or on the base of the flame to better see that reaction, and how to protect myself better. Making sure I have the proper equipment and that I properly sterilize everything that I'm working with in order to get that clear reaction. So a lot of the resources that I used came from this class, the lab notes, and also the lecture in the class. I was able to get the wavelength chart from there. But separate from that, I got from another student how to get the electron configuration. I was actually struggling with that, having difficulty understanding how to actually write out the electron configuration, though through a video that this person provided, I was able to see that it follows a pattern, a specific pattern, and just as long as I follow that pattern and make sure to, in the end, put the leftover electrons, I don't necessarily have to fill up all that can be filled up, and to make sure that I pair up the electrons the right way, make sure that I do everything correctly, I was able to finish that part of the lab experiment. Though my main preparations came with safety in performing the actual lab and making sure I could get the best results possible for the lab. What are the underlying chemistry principles applicable to both flame tests and atomic emission spectra? I would say that definitely the role that electrons play in the bonding of atoms, also the chemical properties of these different substances and how they react and give off energy when coming into contact with heat had a big role to play, and explain the process of writing the electron configuration for one of your metals in a salt compound used. How did you know you did it right? So I talked about this a little earlier in my reflection, but the actual electron configuration can be done by using a chart, kind of a step-by-step building of these numbers. So you follow a specific kind of guide. First you start with 1s2, then 2s2, 2p, so on and so forth, making sure to not skip any. And also, if you have leftover electrons, you don't necessarily kind of force yourself to fill up what's left or what can be filled up, but it's okay to just write the remaining off as it is, not needing to use the available spaces that can be used. For example, I know one of them that had a lot of electrons would be the calcium chloride. That one, I believe, had 54 electrons, and it was a simple task to do. Just follow the guide step by step as it is, or the table, just making sure to go as guided. Now I'll be showing a video of my lab, which I was able to do safely with the help of another person. You'll be able to see my actual reactions that I got and the lights that came off.
Okay.
Lithium chloride. Sodium chloride. Potassium chloride. Calcium chloride.